Hello, so in this video, we are going to be solving minimum cost to fill given weight in a bag. Let's read the question once. Well, the question is of medium level and just a second. Yeah, the question says, given an array cost of positive integers of size n and an integer w, where cost I represent the cost of I kg packets of oranges. The task is to find the minimum cost. Focus on this. The minimum cost to buy exactly W kg oranges. The cost array has one based indexing. All right. If buying exactly W kgs of orange is not is impossible, then we return -1. Okay. There are 2 points mentioned here. First one is cost I equals -1 means that I kg packet of oranges is unavailable. And the second thing is, it may be assumed that there is an infinite supply of all available packet types. Important point to notice. The task here says that you don't need to read any input or print anything. All right, complete the function minimum cost, which takes integers n and w and the integer array cost as input parameters and returns the minimum cost to buy exactly w kg of oranges. If buying is not possible, then yeah, we have to return -1. The complexities that we expected is n times w, n being the size of the array, w being the capacity. Now this question you might have already figured out is very close to knapsack. Okay, what usually happens in a knapsack problem? You have your weight array, you have your profit or value array, and you have to maximize your profit. You have to maximize your profit. This and obviously you have a capacity, right? So this is the usual case of a knapsack. But here, things have slightly changed. What are we being given? We are given n, okay, the size. We are given the cost array, all right. We are given the capacity. But when we talk about weights, slight change is made here. They are saying that weight is actually based on indexing. So when I say this, 20, 10, 4, 50, and 100, I mean that 20 is actually weight of 1 kg of oranges, because here indexing is beginning from 1. So 1 kg orange packet costs 20, 2 kg orange packet costs 10, 3 kg costs 4, and like this. Now what do we have to figure out is, if we have to buy exactly 5 kgs of oranges, in what pattern, what bags of oranges we can buy so that I spend the minimum. Okay, the question is pretty clear. Now the thing is, main point to remember here is this one. It may be assumed that there is an infinite supply of all available packet types. Now once we see this, we know that every packet is available infinite amount of times. So it is up to me. If let's say I have this 3 kg packet having cost 4, I can keep on buying this one. Okay, it is up to me as per my solution. Now here in the second example, we can see n is 5, the size of the array, and then the capacity is 5. But this time there are a few minus ones. Minus ones means that the capacity, not the capacity, but 1 kg bags, 1 kg bags of oranges are not available, 2 kg are not available, 3 and 4 kgs are available at 4 and 3 at cost respectively, and 5 kgs is unavailable. And we have to say, we have to buy 5 kg oranges. See, what is being asked here? We have to minimize the cost. What is given? Cost array is given, our input is given, and the capacity is given. Now, in this case, this problem is actually becoming closer to unbounded knapsack. Okay, let's see this example in this pattern. I have just taken the sample one, the sample test case one here. I have this array and I have these cost. So I have 20, 10, 4, 50, and let's say 100, like this one. And here I have 1, 2, 3, 4, and 5. Okay, I have this bag which is having capacity W. In our case, we have 5. We have to fill it completely. Okay, and we have multiple selection. I can, like multiple times, I can buy one bag also. Okay, let's say I want to buy this bag. What will happen? Its weight is 1 kg. So once I store this, once I buy this one, what will happen? My capacity will get reduced by 1. My capacity will become 4, and the cost that I have will be becoming 20, right? Now let's say now I buy this 2 kg bag. My capacity will get decreased by 2. Okay, it is getting decreased by 2, and my cost is getting increased by 10. Fine. You can still see here that I have 2 capacity left. That means I still want to buy 2 kgs of oranges more. So I go here, I can see, okay, 3 kgs bag is available, 2 kg is not available. I'll buy this one once again, right? So once I buy this bag once again, my capacity will finally turn to 0, and my cost will again get added by 10. So total cost you can see here is 40, right? But now, as you see in this example, the output is given as 14, right? What changes should we make here? We have to optimize it. We are following up with minimum. So we have to calculate the minimum cost here. So for that choice, possibly this is an answer, but not the right one, not the minimum one. So for that, you can see here we have 3 kg bag as well, right? Having the minimum cost out of all. I have this bag. Once I buy this, what will happen? 5 minus 3, I'll be left with 2 capacity, and my value will be added by 4. Cost will be added by 4. And then let's say still 2 kgs are left and I have 2 kg packet here. I buy this one, my capacity will turn to 0, and my cost will be added by 10. Now in this case, my total cost becomes 14, which actually is the minimum. Okay, this is the minimum expenditure that you can do to get this capacity of oranges, to get this total amount of oranges. Okay, so what could be, I hope the question is clear now. So what could be the ways that we approach this question? See, the main thing is, because we have multiple selection and we have to find out about all the possibilities, I will say that I will make all the selections possible. I'll make all the selection possible, and I will keep on storing the minimum ones. Okay, I'll make all the choices. So once I say when I have to make all the choices, we are talking about recursively making all the choices. Okay, now first of all, what could be a choice? There could be two scenarios. If we want to put any any index or any kgs of bag in our knapsack, or you can simply say we have to buy that, what could be the two scenarios? The two major scenarios could be that, let's say you have your bag here having capacity as 5, taking that, and the current weight that we are taking up. Let me just take this thing from here. Let's say we have to make a selection, and because I am using this array and I'm going to be breaking down my array so that I can reach the base case. Let's say I'm beginning from the end. Okay, so this is actually my n, right? N or n minus 1, depending upon how you are dealing with your variables. What will happen? Let's say I have to make the selection for this 5 kg orange bag. So there could be two scenarios. The first one is that my current weight, which is 5 kgs, so that is less than or equal to my capacity. In this case, it is, right? What could be the other case? The other case is that my weight is exceeding. Let's say my capacity went to 3 and I'm trying to make a selection of this bag. It actually has 5 kgs, right? We do not need that. Thus, simply we will not select that. Now, once we select it, see, once we make the selection, there are again a possibility. What? We will talk about that. Another could be that we don't take it, right? Once we have the capacity and it is up to us, we are taking that or we are not taking that. This is the condition we cannot take it. All right. This is a choice that once we are taking it, another time we are not taking it. So how do we take when we talk about recursion? How do we take or how do we not take? So before that, you must be clear with what will be the parameters which will be driving our recursion, or we can say driving a recursive function. For that, we require the general data. So what used to happen in our knapsack case? We had a weight array, we had a value array. Well, in this case, cost contains both the things. The indexes are weights and the values are cost given in the like as these elements. Now the next elements or you can say parameters would be n, which will be driving my recursion. Along with that, I'll have my capacity or w, right? Now once I am making a selection, now it is very crucial and important, listen carefully. Let's say once I am making a selection, that means I am considering this 5, and because we are following the unbounded thing, that means I can the next time too I can make one more selection of this 5. So it is not an end that once I've chosen 5, it is not like that I'm never going to choose it once more. I can choose that. If the condition requires, I can make this choice, right? So for that, if I have to, if I have even a slightest chance that this would be included in my answer in more calls as well, I will in my in the parameters, cost will go as it is. It is simple data, and I will not reduce it. Like if I do not have to make it selection again, I would have reduced n. I would have said n minus 1 because now this is done. I will be calculating my sub problem. But this time, because I can make the selection once more, I am just not subtracting 1 from it. I'm saying n. All right. So now I have to reduce my problem as well, right? So for that, that will be done with w. Because I'm making a selection, because I'm selecting this, the capacity will reduce, right? So I had the capacity of 5, and if I'm taking an packet of like a simple packet of oranges of 5 kgs, the capacity will get reduced. So what we have to do here, I will say W minus this cost array. The element is n, right? This one. Okay, simple. This is how we are making a first choice. How can we make another choice? Well, this time we are not taking the element. And once we are not taking the element, that means W goes intact, no capacity reduced. But once we are not making the selection, that means I'm going to the sub problem and I'm never going to make the selection again. So once I do not have to make the selection, I'll simply say n minus 1 here, right? So two choices made. This is how I'm going to be driving my recursion. One more choice is there. Okay, else if I don't have, like I cannot take that weight because the capacity does not allow it. So in this case too, I'm not going to take the weight. And how do you not take the weight? Cost goes as it is. You go to the sub problem n minus 1 and the capacity does not get changed. Simply the same thing. Okay, so these are the calls, these are recursive calls you would be working on. Okay, now what is going to be my task? The two choices that I'm making when I am capable of like getting an element, in that case, what will I do? I will take the minimum of these two choices, considering this is my choice A and this is my choice B. Whatsoever these choices bring, either A could be minimum or B could be minimum. I have to return the minimum of A and B. Okay, and if this is the answer, this will get returned. Now it would be more clear if we take a look at the code of it. So here is the implementation. Well, I have already used memoization here, so just don't take a look at that right now. I'll explain it later. Just focus on this call. I've made this function min cost, which will be returning me the minimum cost. The parameters that I've passed are cost n minus 1. N is the capacity. I'm already just passing the n minus 1 so that I can deal it as an index. And then I have the capacity W. Okay. Now here, once my function is getting started, I'm taking up the cost n and W here. These are my base cases. Okay. This is the DP and this is my main implementation. So focus here. When I say that n plus 1, n is again my index, and because I'm dealing it as an index, n plus 1 means the capacity, the actual capacity. So when I say, let's say I have this array, something kept at index 4, okay, is actually going to be dealt with 5 kgs. right? So if n plus 1 is less than equal to W, W is my capacity, if I can take the element, and the cost is not equal to minus 1, because it is mentioned in the question that if the packet is unavailable, it means it will be marked as minus 1. Okay, if these two things are satisfied, then we are going to be making two choices. In first one, I am going to be taking the element. Once I'm taking the element, I will include the cost, the current cost, plus whatsoever the sub problem brings me as the answer. All right. Sub problem is, we have already seen that I'll pass on the cost. I will pass on n because I can make this choice again, and then I will reduce my weight. Fine. And then if I'm not taking it, simply whatsoever the sub problem is bringing me as the answer, that is going to be the solution. Cost is going n minus 1 reduced. I'm not going to be taking that nth element again. W, we like it is not getting affected at all because we are not reducing the capacity. Now here, this is the else condition when like this one fails. So when this one fails, we simply have to rely upon the sub problem because that is going to bring us the answer. This is how you do it. Okay. Now, what have I done with my base cases? Take a look here. Well, if my n is getting minus 1 and my w is getting 0, both the things, that means I have reduced my n till minus 1, my all the recursive calls are ended, and the capacity has become 0. That means my function is running successfully and I can simply return 0 here. Done. If I'm encountering n equals minus 1 anywhere in the middle, okay, anywhere in the middle, and the w is still intact, like it still has some value, it is not 0, in that case my solution is not possible. So I have just like returned 10 to the power 9 so that I can deal it later in the main function, and I can say minus 1, so that all the combinations were not able to make the capacity, make up to the capacity. Okay, and after these two base cases I have written if my capacity is becoming 0. Okay, and it could be anywhere in the middle of my array, that I still have some array left, but I have already gotten my answer. In that case also I can return 0. Okay, these were all the base cases. Now coming on here, I have performed simple memoization in which I have made this DP. This is dependent upon the constraint that are given in the question, and this is n cross w. Oh, this matrix is n cross w. N is the size, W is the capacity. Okay, once I've made this DP, simple, I'm checking here. If I've already calculated some value once, I'm going to return that value as it is. And if I am, if I have not already calculated that value, before making my answer, or before, like returning the answer, I will store that in my DP and then return the answer. Simple. And here, like I missed, but you already know that we have to take the minimum of these two choices, right? So this is done. Here you can see, like in the else condition also, I'm simply just saving my data here. The minimum cost, the sub problem one. Sub problems, recursive call, I've stored that in my DP and I've returned that. Fine. Now once this is executed and I have received my value x here. Now if my x is greater than 10 to the power 9 because I have used it once, that means this indicates that the problem was in we were not able to make up the solution for that, and in that case I have to return minus 1. That I will do here. If x is anything other than that, I will return x simply. Okay, so again this problem is a slight variation, but if you are clear with the concept of knapsack, it is not going to be a big thing for you. Now talking about the complexity, well, it is going to go n cross w, because we are making all the choices possible and we are optimizing it using some space that we are taking here. Okay, we are making all the possible choices. All right, so let's try to run this code now. All right, let me compile this code. It's getting compiled successfully, giving us the right answer. Let's try to submit that. And okay, it has passed all the test cases. So I hope now you have understood the problem well. If you have any doubts, you can drop that in the comment section. We will try to answer that there. And if you like the solution, do like the video. Thank you.